So this is a lesson about how to go from standard form of a quadratic equation down to factored form. But in order to do that, I want to go from factored form, that's why all of these are in factored form, to standard form, which everybody should be good at doing, just multiplying out. In order for us to look for some patterns maybe on how to get from, once we are in standard form, how to get back to factored form. Okay, so everybody should remember from yesterday that when we're going from factored form into standard, we just need to distribute it all out. So we take the first term of everything to each term of the second, and then after we're done with that, we take the second term, come here, there it is, the second term of every first factor to the terms of the second factor. So I went ahead and did that. That's what all of these are. And if you notice, I did make all of these very, 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 very similar. The only difference in these four factored forms is the pluses and minuses change. So I've gone from both plus to 1 plus 1 minus, switched the plus and the minus to both minuses. We still have all the same numbers when we multiply it out, but again, the signs are different. And then hopefully we remember from yesterday that we need to combine these like linear terms in the middle. So I went ahead and did that. And then I just want us to look for some patterns here on if we see a standard form, how does that help us get back to the factored form? So if you notice, each one of these, the two linear terms, the 5x and the x, they directly lead to the first term of every answer. All of these answers are 5x squared, right? And then separately, the constant term of each of the factors, so 1 and 3, always leads to the 3. Now, sometimes the signs make it a negative 3, and that happened when we did a positive times a negative, right? Positive times negative is negative. Even when we had two negatives, though, we went back to positive because negative times negative is positive. So if we're trying to get from standard form back up to factored form, one of the things we want to keep in mind is that the numbers at the end and the number at the beginning are directly caused by the numbers that are in there. So keep that in mind. We'll use that here in a minute. And then the number in the middle, the green number for you guys, is a combination of when we took the linear term times the other constant. So that was the 5x times the negative 3, and then this constant times its linear term, right? So constant times the linear gave us these, and then we combine. And what we're going to need to look at is how in the heck are we going to use that number to help us decide which things are positive, which things are negative, which order do they go in. So we will be looking at that. Okay, and then one more quick thing. If you remember from yesterday, we did have some factored forms that looked kind of like that with a number other than 1 in the very front as the rate of change number. I'm sorry, as the a-value number. So this one has a 4 in the front, and if you remember, you can multiply that however you want. A lot of you would take the 4 times the first factor and then multiply your answer. Since I've already multiplied out 5x plus 1 and x plus 3 above here, I was just lazy and used it, and I waited on the 4. And then I was going to multiply the 4 in last. So it looks something like this. So I want you to keep in mind when we're going back from standard form back to factored form, we do need to look and see, do all the numbers have something that divides out of them nicely that we can take out immediately? So if we're going backwards, we would need to notice that each of these is divisible by 4 and take that 4 out to undo that distribution. And then it'll make the rest of the factoring much easier. So you'll see that as we go along. All right, so let's start looking for some more solid patterns. Besides just that the first number and the last number, I'm sorry, the linear pieces give us the first number and the constant pieces give us the last number. Let's check this stuff out. Okay, so every time we multiply together to get a quadratic, we have a linear and a constant, and it may say plus or minus in between here and plus or minus in between here. We take our linear times our linear when we distribute, and linear times linear is always going to give us quadratic, right? There we go, go away. All right, So linear times linear is going to give us quadratic. Then we've also got to take the linear times the constant. That's going to give us a linear times a constant term is going to give us still a linear. And then we also do that here, linear times constant again. That's why I made them both green. And then those are the terms that we end up combining to get our linear term in our final answer. So linear times constant, linear times constant. And then lastly, we have to take that c times that c, and that's going to give us constant times constant. It's going to keep us with our final constant. Okay, so the quadratic term at the beginning and the constant term at the end are actually really predictable. If we can see what the last term is and the first term is, usually it's pretty easy to determine what number should go there. But the green stuff, the stuff that looks a little more complicated, that's going to tell us what signs are going to be on in our parentheses, pluses or minuses, and where things need to specifically go. Okay. So what I'm going to have us do is each time we get quadratic in standard form, I'm going to have us make a table of all the possibilities that could have caused the quadratic and all the possibilities that could have caused the constant. And what you'll see is we'll always be looking for, if the c is positive, we'll be looking for things that sum to be the middle term. If the c is a negative constant, we'll be looking for things that have a difference of the middle term. Okay, let me show you what this kind of looks like. So I've got 3 examples here. All right, so we're in we're in standard form, and we want to go to factored form. So like I said, I want us to focus on what causes x squared. So what's the only things we could have multiplied? So remember, we'll have our 2 parentheses here in a minute. What's the only things that we could have multiplied to get x squared? So what times what equals x squared? And hopefully everybody's thinking x times x is x squared. So we know that when we write out our parentheses for factored form, or 2 sets of parentheses, we'll have an x and an x in them. Now, the 24 has a few more possibilities. There are lots of things that can multiply to 24. I went ahead and listed them all out. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Okay, so when we write our parentheses here in a bit, we'll just stay right. When we write our parentheses here in a bit, so far all we know, ooh, that was a good one, is that we'll have x and x, because that'll cause the x squared, but we have to decide which of these guys do we want to go here and here in order to get the 24, but also to cause the negative 10. And that's the hard part. What's going to cause the negative 10 in there? So what we need to look at is, remember I told you on the last slide that if the c was negative, we were going to call this a difference table. And we would look for things that have a difference of the middle term. So we're going to look for things that have a difference of 10. So if we would take, get out my green, if we would take and use these guys, so our linear times our constant and our linear times our constant, that's supposed to cause the middle, we'd have a 1x and a 24x, but those don't have a difference of 10, they have a difference of 23, so that's no good. If we choose the second possibility and did x times 2 is 2x, x times 12 is 12x, 12x and 2x actually do have a difference of 10. So those are going to be the ones that we want to pick. So we know that we want x and 12 and x and 2. Now we just need to decide on our signs. And again, our signs are going to be determined by our middle term. So in order to get a negative 10x out of, remember we picked these because we have 2x when we would multiply together, and we would have 12x when we multiplied these guys together. Now if we want a negative 10, we need to make our 12s be negative and our 2, be positive, right? Because those would combine to have a different, or they would combine to have, combine to be negative 10. So if I make this a negative 12 and a positive 2, let's just check this out real quick. Let's just distribute it out to make sure we're right. Oops, I need that. So x times x, that's giving us our x squared, right? That's what we wanted. Then linear times constant There's our positive 2x we were hoping for. My writing is great like this. And then the negative 12 constant times the x is negative 12x. Right? And then finally our constant times our constant is giving us our negative 24. Woo! There we go. And then we would combine our middle terms, positive 2x and negative 12x would give us our 10. So we know we did it right, because if we distribute this out, we end up getting our original standard form. All right, I'm going to try and avoid writing as much like that. Let's try another one, because I know this is kind of weird. Okay, so with this second example, again, first we're going to look at what causes the first term. So what causes x squared? And we already know that's just x times x. Then we're going to look at our last term. What causes a negative 45? And I wrote out all the possibilities. And I do recommend you write out all of them and in order, starting with 1 and then building up. Okay, now we need to figure out, first of all, this is a negative 45, so we know this is a difference table. So we'll be looking for a combination that have a difference of the middle term, so a difference of 12. So let me grab my pen. So if we did 1 times x, that'd be a 1x, and 1 times x times 45, that'd be a 45x. But those have a difference of 44, so that's not going to be what we want. So let's get rid of that. If we try the next possibility, we've got a 3x. Whoa! Let's try again. 3x and a 15x. Right? And those actually do have a difference of 12. So we know that that's the possibility that we want. So we know we want x and x and 15 and 3. Now we just have to decide what signs do we want. So again, we're always focusing on our our linear times the constant and our linear times the constant. So there's our 3x. Ooh, 3's are hard to make on my laptop. 3x, and here's our 15x. If we want a positive 12 out of this, we've got to do a positive 15 and a negative 3, which tells me that this 3 needs to be negative and this 15 needs to be positive. And then we could, if we wanted to, distribute all of this out, x times both things, 15 times both things, but we should end up here. Okay, so let's try another one. All right, so this next one's a little bit more difficult, and only because there's now a number in front of x squared. Luckily, 7x is not too bad to work with. What are the only things that cause, what times what would cause 7x squared? Well, our only choice is really a 7x times a 1x. That's really it. And then our possibilities for our constant of 3, again, that's not so bad, it's just one thing. Okay, so we've got our possibilities, but we have to be careful now. Oops, didn't mean to scroll down. There we go. Do we want to multiply the 7 by the 1, causing a 7x, and the x by the 3, causing a 3x? Oh, by the way, is this a sum or a difference table? If we've got a negative 3 up there, we know we're looking for a difference of 20. So just looking at these two numbers, do 7x and 3x have a difference of 20? No, they definitely don't. They have a difference of 4, right? They're only 4 away. So I don't want to link the 7 with the 1. Maybe instead of doing that, let's erase that real quick. Instead of doing 7 with 1, let's do 7 with the 7x with the 3, which would be 7 times 3 would be a 21x. And then the single x with the 1, which would be a 1x. And then 21 and 1 do have a difference of 20. So this is the way I want it to be. So we have to be careful with this. So if you notice when I pulled this one up, all I have showing are the x's. I didn't actually fill in the numbers because now it's going to matter where I put the 1 and the 3. In the previous example, since they were both x, it really didn't matter where I put the 15 or the 3 because it looked the same. Here, now it matters. Okay, so we said we want the 7x to be multiplied by the 3. So when we're distributing, the only way that's going to happen is if the 3 is in the other parentheses. We never multiply inside the same parentheses when we distribute. So I know I need the 3 to be here so that I can get my 21x when I distribute this out. And I know that I need the 1 to be linked to the x. And there's my 1x. And now we just need to talk signs. Okay, so we needed a negative 20. So I need this guy to be negative and this guy to be positive, which means I need the 3 to be negative and I need the 1 to be positive. And again, if we wanted to double check this, we could distribute it all out. 7x times both things. So 7x times x would be 7x squared. That's what we want. 7 times negative 3, there's our negative 21x. Now 1 times both things, 1 times x is 1x, so if we would combine those like terms, we'd get the middle, and then finally 1 times negative 3 is negative 3. So we'll know we did it right. Okay, so I know this is kind of weird. I'm going to do 3 more examples, see what we can do, just to practice. Okay, so this is actually very similar. I'm going to flip back to the slide right before this. We had x squared minus 10x minus 24. Now we have x squared minus 10x plus 24. We haven't done a plus yet. Remember, if that c value is positive, now we're doing a sum table. So instead of looking for things that have a difference of 10, we'll be looking for things that have a sum of 10. All right, so let's list out our possibilities. So our possibilities for x squared are easy. That's x and x. Our possibilities for 24 are a little more complicated. We've got all of these possibilities. Okay. Now we're looking for how can we multiply x by things so that our results have a sum of 10. And don't worry about the negative. We'll deal with that when we write out our parentheses. Okay, so we want a sum of 10. So if I link x with 1, oh, I want that to be green. Let's go green. If I link x with 1, that's a 1x and a 24x. So 1x and 24x definitely don't have a sum of 10. They have a sum of 25. So scratch that. If I link x with 2 and x with 12, that's what we did last time. A 2x and a 12x had a difference of 10, but now we know we want a sum, and they have a sum of 14x. So that's not helpful. Here we go. If we do 3x and 8x, those have a sum of 11x, which is close, but not what we want. So finally, if we try 4 and 6, we've got a 4x and we've got a 6x. And those do have a sum of 10. So we know we want x and x, 4 and 6. And again, it doesn't matter if I put the 4 here and the 6 here, since it's both an x, it doesn't matter the order. Now we just need to figure out signs. So in order to get a negative 10 from these two numbers, I know that I want to have a negative 4 and a negative 6. So that would give me both negatives up here. Ooh, that was a big one. Shrink that up a little bit. Oh, goodness. All right, so we've got x minus 6 and x minus 4. And we can always check this by distributing it out. X times x is x squared. X times negative 4 is a negative 4x. Then negative 6 times x is a negative 6x. So negative 4x from before, negative 6x combined to be our negative 10. And finally, negative 6 times negative 4 gives us positive 24, which is what we wanted. So we know we did it right. Okay, let's do another one. So we've got a number in front, which we know makes things a little bit more complicated. So possibilities for 2x squared are going to be just 2x and x. Possibilities for 15 are going to be 1 and 15, 3 and 5. Since that 15 is positive, we know we're doing a sum table. All right, so let's figure out what we want. We want a sum of 11. Again, don't worry about the negative. We'll do that later. Sum of 11 when we multiply these. So let's try some possibilities. If we do 2 times 1, that'll be 2x. And 15 times x will be 15x. So 2x and 15x have a sum of 17x. That's not what we want. But what if we switch that? What if we went the 2 times the 15? That'd be a 30x, and the x times the 1 would be a 1x, but 30x and 1x have a sum of 31x, not 11. So we do not need to link up to 1 and 15 at all. We know that that's no good. So let's try here. Let's just do the 2x times the 3 and the x times the 5. So that would be a 6x and a 5x, and that is what we want because those have a sum of 11. Beautiful. So I went ahead and put the 2x and the x in there, but we have to be careful anytime it's not just x and x. We have to be careful where we put our numbers here. It will matter if I put the 3 here and the 5 here, or switch that, the 5 and the 3. So we have to be careful. Okay, I know I want the 2x to link with the 3. So if I want that to happen, the 3 has to be in the other parentheses so that I can actually multiply the 2 times the 3. And then that would mean that the 5 would go here so that I can link it up with the 5 and the x. And then we need to talk about signs. So here was our 6x, and here was our 5x. And in order to get a negative 11, the 6 will have to be negative, and so will the 5, which means both of these guys are going to have to be negative. And again, we could fully multiply this out to see if we were truly correct, and I always recommend that you do that. Okay, one more. Okay, first thing to notice about this. We could write our possibilities for 2x squared here and our possibilities for 28x here. But hopefully you notice that each of these is divisible by 2. So really, it's like somebody multiplied a 2 into this set of parentheses. 2 times x squared, 2 times 5 would be the 10, 2 times 14 would be the negative 28. Always take out any number that you can, pulling it out to see what it was before it was distributed, because then the quadratic you have left might be much easier to work with. Notice that now we just have an x squared, which limits our possibilities, and it's so much easier when it's just x squared. And now our constant is 14, which has less possibilities than 28, so that's good. There we go, 1 and 14, 2 and 7. Since that 14 is negative, we know this is a difference table. So we're looking for things that, when we multiply, have a difference of 5. So let's try some possibilities. And the more you do this, the more you're not going to have to test every one. Like you'll start seeing the answer really quickly. Okay, if we did 1 times x, we'd have a 1x, and x times 14 would be a 14x. So 1x and 14x have a difference of 13. That's not what we want. So get rid of that. Let's try it here. X times 2 would be 2x, x times 7 would be 7x, so 2x and 7x, that is what we want because those have a difference of 5. So, we've got the 2 out in front, the x and the x. Since it's an x and an x, it doesn't really matter where I put the 2 or the 7. I could put the 2 here or on the other side, and I could put the 7 here or at the other parentheses. It doesn't matter since these are both x's. It only mattered on problems like this, where it wasn't a single x. And then, all right, let's talk signs. So we have a 2x when we multiply, and we have a 7x when we multiply. And we want a positive 5. So that means the 7 will have to be a positive, and the 2 will have to be negative, so they combine to be a positive 5. So we need the 7 to be positive and the 2 to be negative. And again, we can multiply this out and see if we're right. Okay, hopefully you remembered some of that back from Algebra 1. We'll be practicing a lot with this in the next couple of days. I'm also going to put up one more video that has just more examples if you want to see them. Okay?